As the marks in question 12 have been allocated, you can see that part A is fairly straightforward and part B has a bit of a sting in the tail. Part A, then, you're just asked to complete the diagram or the probability tree diagram for this question. You're told that if he wakes up early, the probability that he is on time for work is P. Now, from this, you need to deduce that these two events, on time and late, those are the only things that can happen. Therefore, these two probabilities, this one here and this one here, must add up to 1. So if this first probability is P, this second one must be 1 minus P. And we're also told in the question that if he wakes up late, which I'm sure none of you have ever done, if he wakes up late, the probability that he's on time for work is going to be 1/4. So that's this one here. And again, we need to deduce that if the probability that he's on time for work is 1/4, the probability that he's late for work is 3/4. So that's going to give you your 2 marks for part A. For part B, it says the probability that Mr. Van Winkle arrives on time is 3/5. So we know that probability on time is 3/5, and from that we're asked to deduce the value of P, which is an altogether different proposition. So we need to recognise that there are in fact 2 ways that Mr. Van Winkle can be on time. The first one, let's do this in a different colour, is that he wakes up early and arrives on time. Now, if we're going along the branches of the tree diagram, we need to multiply together. So the probability that he wakes up early and arrives on time is going to be 4/5 multiplied by P. The second way that he can arrive on time for work is that if he wakes up late and then still arrives on time for work. And again, going along the branch of the tree diagram, we need to multiply. So the probability that he arrives on time and he's woken up late is going to be 1/5 multiplied by 1/4. So we can simplify that. This is going to be 4p over 5, and this one is going to be 1 over 20. Now, we know that both of these outcomes are possible. Both of these outcomes are possible for him to arrive on time. So we know that to find the probability he's on time, we're going to have to add up both of these. So the probability that he's on time, that he arrives on time, is going to be this one, 4p over 5, plus this one, 1 over 20. And we know from the question that this actually is equal to 3/5. Now, at the moment, it's a bit nasty. We need to figure out a lowest common denominator in order to calculate the value of P. So the lowest common denominator for all of these is, in fact, going to be 20. Now, I'm just going to manipulate this as I do it, but 4p over 5, we need to multiply the numerator by 4 to get to 20, so I need to also multiply the denominator by 4. So that's going to give me 16p over 20. Is going to give me 3 over 5. So again, multiplying the denominator by 4 to get 20. So I also need to multiply the numerator by 4. So that's going to give me 12 over 20. And then I'm just going to take this over to the other side because it's already over 20. So I end up with this 16p over 20 is going to be 11 over 20. So the 20s are going to cancel out, and we'll end up with 16p is going to equal 11, so therefore p is going to equal 11 over 16.